This is PreCalc 11, Chapter 4.6. We're going to be analyzing quadratic functions in the standard form. And we need to be able to find functions in different forms. It's no different than doing it in standard form. We substitute the known coefficients and points, then solve the unknowns using algebra. So a graph is not required. For example, find the function in general form given a is equal to 2. And we're given the points a is equal to negative 2, 10, and b is 2, negative 6. So we'll start with point A. We substitute the x and y. 10 is equal to 2. We substitute 2 for a. And we have negative 2 squared plus b, negative 2 plus c. So we have 10 is equal to 8 minus 2b plus c. The easiest one to solve for to substitute is c. So let's move the 8 over to the other side. So that's negative 8. 10 minus 8 is 2. Negative 2b becomes plus 2b. And that's equal to c. Let's substitute point b in. We have negative 6 equals 2 times 2 squared plus b times 2 plus c. When we simplify, we get negative 6 is equal to 8 plus 2b plus c. Bring the 8 over to the other side and we have negative 14, and the 2b becomes negative 2b. Now we have these two equations we can put together. 2 plus 2b equals negative 14 minus 2b. Bring the 2b over to the other side, we have 4b. Bring the 2 to the other side, and we have negative 16. So b equals negative 4. We can plug the b back into here. We have 2 plus 2 times negative 4 equals c. So c equals 2 minus 8, that's negative 6. Plugging everything back into the beginning, we have y is equal to 2x squared, because a is equal to 2. B is minus 4x minus 6. And that's our equation. We need to be able to determine the characteristics from different forms. So we have the same equation in the different forms: standard form, general form, factored form. Right away, we can say concavity is up because a is greater than 0 for all of them. And we can calculate the y-intercept by plugging in 0 for x. So here we have 2 times negative 1 squared minus 8. That gives us 2 minus 8, that's negative 6. Here it's just a constant term, negative 6. Here we have 2 times 1 times negative 3, that's negative 6. 2 times 1 times negative 3. Now for the axis of symmetry, I should fix up the colors here. Axis of symmetry. We can determine it from P, so x equals 1. Axis of symmetry. We can calculate this from x equals minus b over 2a. So minus negative 4 over 2 times 2. We get 1. 2 negative signs is positive. And in this form, we simply do negative 1 plus 3 over 2. That's 2 over 2, and that's 1. We average the two x-intercepts. Vertex. We can now compute the vertex. We plug in 1 into here, so that's 2 times 0 minus 8. That's 1, negative 8. Here we plug in 1 to here, we get 2 minus 4 minus 6. So again, that's 1 minus 8. We plug in 1, we get 2 times negative 2. That's 1, negative 8. The minimum value, since we have the vertex, it's just minus 8, minus 8, minus 8. And we can do the range. Since it's concave up, we have y is greater than or equal to negative 8. And it's just the same all across. The discriminant, we can't easily do it here. The discriminant is b squared minus 4ac. So that's negative 4 squared minus 4 times 2 times negative 6. This is 16. This is negative 24, negative 48. So we have 64. And again, we can't easily calculate it here. The sign of the discriminant is minus a times the y-coordinate of the vertex. So we have minus 2 times negative 8. So the sign is positive. Again, we've already calculated the discriminant, so the sign is positive. And here we can tell the discriminant is positive because we have greater than 1 x-intercept. The number of x-intercepts, since it's positive, the discriminant is greater than 0, therefore 2. And that's the same reason all the way across. For the x-intercepts, we can't easily determine them. Here, again, it's not easy, but we can use the quadratic formula. And here, since it's in factored form, we know x equals negative 1 and 3. So, this one, this one, this one, this one, this one, this one, all need to be calculated after the axis of symmetry is calculated. When we're graphing by hand, we use the characteristics to help us get a more accurate graph. You can always determine the axis of symmetry and therefore the vertex. And you can always determine the y-intercept and concavity. And if you can easily determine the x-intercepts by factoring, then do so. So from the previous example, we have our vertex. So we have our vertex at 1, negative 8 from our calculations. We also have our axis of symmetry, x equals 1. We know our y-intercept is negative 6. And because of symmetry, we have this point. So the distance from here to the axis of symmetry is the same as the distance from here to the axis of symmetry. And finally, from the factored form, we have these two intercepts. And then we just smoothly join the points. And that's about as much as you need to do for the graph. Marks will be deducted for any missing easy characteristics. So, modeling functions. We have a choice of where to place the origin, and sometimes where you place it will make it easier for solving. So our example is we have a parabola It's 8 meters high, it's 30 meters wide. So if we put it at the origin, this point is now 15, 8. This x-intercept is 30, 0. If we put the origin here, then this vertex becomes our y-intercept, and we have x-intercepts that are opposites of each other. So this is negative 15, this is 15. If we put the vertex at 0, 0, these are no longer x-intercepts. We have this height as negative, and the x-coordinates again are opposites of each other. So how do we model this? We have this formula. We just plug in a point. 0 equals a. Plugging in the origin is an easy point. And we can determine a. So negative 8 equals 225a. So a equals negative 8 over 225. So our formula is y equals negative 8 over 225, x minus p, p is 15, squared, plus q, and that's 8. In this factored form, we plug in our point. This point's easy. 8 is equal to a. This is 0. We know what the factors are. We have negative 15 and positive 15. So we have 8 equals negative 225a again. So a equals negative 8 over 225. And we just plug it in. Negative 8 over 225, x plus 15, x minus 15. And lastly, the easy point to plug in is, we don't want to plug in 0, 0, so we can plug in this one or this one. If we plug in 0, we just get 0 equals 0a, so that doesn't help us solve a. So let's plug in this one. Negative 8 equals a times 15 squared. So negative 8 equals 225a. A equals negative 8 over 225. So we have y equals negative 8 over 225 x squared. So placing the parabola with the vertex as the origin probably looks like the easiest way to solve this problem. And again, you can see that each one has the same leading coefficient. But whatever form you're comfortable with to model your equation, go with it. And that completes this lesson.